Hi everyone and welcome to our office hours. So we are gonna start in a few minutes, but before, let's introduce ourselves. My name is Anna Vedoveli. I am a data scientist in our customer care team here in Germany, in Constance. And today I have with me my colleague, Satoru Hayasaka. He is a data scientist also in the evangelism team in our office in Austin.
Hi, I'm Satoru Hayasaka. I'm located. I'm a data scientist. I'm part of the evangelism team. I'm located in Austin, Texas, in U.S., and I'll be covering some of the portions of today's office hours.
Great, good. So before we start, I'm just going to explain how this is going to work. So let's click. Oops. Yes. So we are going to have a main session here where Satoru and I we're going to be covering some of the common questions we get. So please use the chat we have in this meeting to post your questions, and we're going to answer those as we go. So this webinar is going to be recorded and made available on YouTube. So in case you also want to see, the main session is going to be recorded, not what is you guys talk in the breakout rooms. So today we are going to talk about, in the main session, basically about 4 different topics. So we're going to be talking about data access, data wrangling and machine learning, collaboration and sharing with KNIME, and deployment options that we have in KNIME. And we are going to have 15 minutes for each topic we're going to be covering in the main session. In parallel, we are going to have what we call our breakout rooms, where you can join some KNIMers to ask them questions, whatever you have for 15 minutes. So today I have 4 of my colleagues with me in their breakout rooms. I have Paolo and Catherine. They are both data scientists in our evangelism team here in Germany. I have Jenny. She's a life science data scientist in Germany as well. And I have Roland, who is a product owner and data scientist in our customer care team. So you can join them in their breakout rooms as soon as we start. And here in the main session, we're going to be going through some of the most common questions we get and also talking a little bit about them. So I think that is it for our housekeeping. So I think now everyone can be assigned to their breakout rooms. Those of you who wanted to be assigned. And I think then with that said, let's get started. So let's talk first about data access and have a look at one of the questions that we get most commonly with data access. Click, click, yeah. So one of the most common questions we get during courses or during presentations that we have is usually like, what can I connect to? Can I connect to the Oracle database, or can I connect to Microsoft Access, or to Cloud Data Impala, or to Amazon S3, or to Athena, or to Google BigQuery? So basically, what KNIME can connect to? And to answer that, I'm going to let Satoru pick up. Satoru, do you want to?
Yep, sure. Okay, so let's see. So the short answer to that question is yes. You can connect to different types of databases with dedicated connector nodes available as part of KNIME database extension. And so here are examples of some of the nodes that are available in KNIME. So there are nodes for H2, Microsoft Access, Microsoft SQL Server, MySQL, Oracle, Postgres, and SQLite. And in addition to that, so there is an extension called KNIME Big Data Connectors extension, and as part of it, you also will be able to connect to Hive and Impala. And so once you you find a dedicated connector node that you are going to use for the type of database that you are dealing with, and you can configure the connection information such as the location of the database and authentication method with that particular database node that you are going to use. So let's see. And so if you cannot find a database connector node specifically designed for your database, the type of database that you want to access, and that's still not an issue. So there is a generic DB connector node available in KNIME, and you should be able to configure that node by registering a particular JDBC driver associated with the database that you want to use, and you should be able to configure the connection based on that. And so at this point, let me show you real quickly. Let's see. So these are 3 examples of connector nodes, and so the first one is SQLite connector, and so I'm going to open up the configuration window. So SQLite is a file-based database. So in this case, all you need to specify is basically the location of the file, and that's all you need to do. And so in this case, I happen to have this file on my computer, and so I'm just using the file location on my computer, and that's all you need to do in this case. And so then once you do this, then the connection information is actually passed on to the downstream from here, and you'll be able to do different kinds of database processing. And MySQL connector, on the other hand, for example, so this is designed for a remote server, and so in order to access this, you probably need to set up a little bit more details into the configuration. So in this case, you have to specify the location of the host, for example, and the database that you're accessing, a port number, and so on and so forth. And you also need to specify some sort of authentication method. So in this case, I'm going to be using username and password, and you'll be able to select all these, specify all these information within KNIME, as you can see here. And so your database doesn't exist. So there is no DB connector node for the database that you are trying to connect. That's not really an issue. So here's a generic DB connector node. And if you look at the connector node configuration window, this is what it looks like. And so some of the default drivers are already available. These are the drivers that are already available pre-installed on KNIME. But let's say you want to connect to a different type of database. In that case, well, first step that you need to do is to install a driver that you're interested in. So you just download the driver for whatever the type of database that you are going to be using, and you basically install that driver. You basically specify that driver in under preference. So under preference and under KNIME, there's a menu called databases. And so in this particular case, I've already added this driver for a Google BigQuery. And so in this case, you'll be able to specify some of the informations, ID number, name, and URL template, and so on and so forth. And you just specify the file name here for the downloaded driver is specified right here. And once this is set up, then so this driver is now available inside this DB connector. So if you try to take a look at this DB connector, and you'll be able to select BigQuery. Yeah, so BigQuery. So this is the driver that I just installed. And so you'll be able to see now that it's visible inside your DB connector. And so then you'll be able to set up all the other information associated with that particular DB connector node. And so that is how you'll be able to establish connections to different types of databases. Okay, so let me get back to the slides. So those are for databases. And how about remote file handling on cloud storage? And so the answer is still yes. So there are dedicated nodes that are available for different types of cloud storage services, such as Amazon AWS, Microsoft Azure, and Google Cloud. And in addition, like for some of you who may be still using FTP and HTTP, all these file transfer protocols, and those connection nodes are also available in KNIME as well. And KNIME Analytics Platforms has all these nodes dedicated for all these different services, and you can upload or download files. And you can create directories, you can delete files or directories, or you can get a list of files from through these services. So here is an example workflow. So in this case, what's happening is that so in this case, so we are trying to create a bucket in Amazon S3, and we want to upload files there. So in this case, what's happening is that so we try to establish a connection to Amazon S3 by entering credentials using one of the connection nodes that is available in KNIME Analytics Platform. And then we create a new bucket to be housed in Amazon S3 by creating directory, all these directory structures that is going to be used inside inside Amazon S3. And I can also create, so in this case, I'm also creating a list of files that are to be uploaded from your local file system to Amazon S3. So I'm creating a list of URIs to be uploaded. And I'm combining all this information into this upload node. And finally, I'll be able to upload all this information up to Amazon S3 platform, as you can see here. So, so there's another question related to data access. So this is one of the things that we hear often. So some people are loading files in Excel, and I see that there are different ways I could read my files from my local system, from mount point, or from URL. What does it mean? What are the relative paths? How and when should I use them? So this is a really good question. First of all, there are two dedicated KNIME Reader, dedicated Excel Reader nodes in KNIME. One is Excel Reader node. The other one is Excel Sheet Names node. So this one reads a spreadsheet, one of the sheets, whereas this one reads a list of worksheets from Excel file. Now, these are three different ways to specify location of the files using three different protocols. So so this one is absolute URL. So this one is helpful if you happen to have mount point to a server, then you'll be able to specify the file located in that particular server. The other approach is to use local path. So this is basically to specify a location of the file that resides in your local computer by specifying all the series of directories leading up to that file on your local computer, on your hard disk. And the third way is to use custom URL. So in this case, this is a relative path in relation to the workflow that you're using right now. And so in this case, we are going one directory, two directory above, and there is a data folder called data, and there is a file called product data2.xls. This notion is very useful when you're sharing a directory, for example, among team members. Then in that case, as long as the directory structure is preserved, then you'll be able to access files through this through relative addressing. Okay, so that was the first portion of this office hour, and now we are moving on to data wrangling and machine learning section of the office hour. Okay, so so here's another question that we get from the users. How can I compare multiple models and select the best one? How can I use an ROC chart that combines multiple models? So in order to demonstrate this, I'm going to move over to a workflow with multiple models. So for this data flow, what I'm going to be doing is, first I'm going to be using this data set that has, so I'm going to show you the data set itself. So it has a demographic information about customers for a certain firm. And so in this case, our goal is to predict this column target, which is a binary column, based on all these other available features in this data table. So that would be our goal. And so in order to do this, so we have this data set. So I'm going to partition this data set into training and testing data set, as you can see here. So 80% of this goes into the decision tree. Oh, sorry, 80% of this going into the training set, remaining 20% going to testing data. And one thing I failed to mention here is that so this is going to be a binary classification, and so we try to at this case we use a stratified sampling so that the ratio of one class or the other is fairly preserved between the class when we're splitting into training and testing data set. And so I have three different classifiers: decision tree, random forest, and the gradient boosted tree. And so these classifiers are trained in a typical manner. So first, the training data set is fed into the learner node, and the model is generated, model is trained, and the trained model is used on a testing data set to generate the predicted outcome. And once the predicted outcome is generated, then I'm going to be using the scorer node just to evaluate the performance of a classifier. So let's say, for example, if I take a look at the classifier results from the decision tree, so this is what you see. These are all the statistics that is generated by this classifier. And one of the tables that is generated by scorer node is this one. Overall statistics. So in this table, this is a fairly simple table, as you can see. So it has a overall accuracy, overall error, as well as Cohen's kappa associated with this particular model. And I'm adding an extra column to this output table of overall accuracy. So what I'm going to be doing is I'm adding an extra column here called model with a name of the model that we used. So in this case, decision tree. And so we have run all these three different models simultaneously for this particular data set with this particular partition. So I have all these overall accuracy table for the both random forest as well as gradient boosting as well. So at this point, we're going to combine all these overall accuracy tables from three different methods together into a single table. And so in this case, I'll be able to see that all these overall accuracy statistics as well as Cohen's kappa in a single table for different models. And once you have this in a single table, then you'll be able to use a sorter node to basically see which model produced the most desirable result in terms of the criterion that you'd like to use. Let's say, for example, if I try to focus on the overall accuracy, and in that case, random forest probably would be the best bet, followed by decision tree and gradient boosting. So in this case, I'm just exporting all these overall accuracy statistics alone, but you can also export the data, the model itself as well. So some of these output are PML object, and if we use this node called model to cell, for example, then we can convert this model into a cell that can be housed inside a data table. So we can basically embed the model into the output table using for example, a joiner node or something like that to combine that information, combine the model as well as the overall statistics, so that you'll be able to basically use one of the winner models to be used for subsequent processes. And so that was how we can see, we can compare the overall statistics. And so the question next will be, how can we combine prediction probabilities and generate RC curves from multiple models. And so in order to do this, as you recall, if you want to generate an RC curve from your model, you need to specify in your configuration window to add a column with class probabilities in addition to the predicted labels. Okay. So that's what we did. And if you take a look at the output table, you'll be able to see that the prediction probabilities are also added in addition to the predicted label in this testing data set outcome. And you do this for 3 different models. And so what you end up happening is that so predicted probabilities for 3 different models are generated. And at this point, I'm going to be combining all these prediction probabilities from different models using the joiner nodes, a series of joiner nodes in this case, combining decision tree and random forest, then adding gradient boosting in addition to that. And so at the end of the day, so I'll have this joined probability table. And so we have all these probabilities for predicted classes for different predictors. And I'm going to be doing a little bit of cosmetics here, so a little bit of beautification by changing the column names from probability target equal 1 dt into, let's say, for example, decision tree or random forest and gradient boosting. And once I do this, I can just simply use the ROC curve node to generate RC curves. And so in this case, if you take a look at the configuration, so you'll be able to see that I just need to specify the class column and as well as a column that house all these different probabilities. And in this case, you'll be able to select all these multiple columns of probabilities, as you can see here. So these are the probability estimates from decision tree, random forest, and gradient boosting. And once you have this information, then you'll be able to generate RC curves in the same plot. So let's see. So yeah, so in this case, you'll be able to visually appreciate the difference between different models in terms of their performance as summarized by ROC curve. And so in this case, so different models are, of course, drawn by different colors. And in this case, again, random forest seems to be the favorable one. So in this case, the area under the curve was 0.85, so which was much larger than the other 2 models. The other 2 models, the area under the curve was very similar. In fact, you can kind of see that decision tree and gradient boosting, they sort of like, in terms of ROC curve, their performance is very similar to each other. Okay. And so that would be how you can basically combine all these ROC curves from different models, and you'll be able to examine them together. So now let's go back to the PowerPoint.
Yes, thank you, Satoru. I just want to reinforce that if you have any questions related to data access or to data wrangling and machine learning, don't feel embarrassed of asking in the chat. So it doesn't need to be related to the use case we are presenting. It can be anything that you always wanted to know. Just write on the chat, and we are going to discuss this here as well with everyone else.
Okay. Thank you. And so here's another question about, so this one is about data wrangling. So I often work with the big quantities of data that is stored in a database. Do I have to load this data to KNIME to manipulate it? Or what is the difference between the database processing nodes and KNIME's processing nodes? What is the advantage of working in a database? So, of course, once your database is connected, once you're connected to the database, then you can do different operations using database manipulation nodes as opposed to using native KNIME nodes to do the same kind of processing inside the KNIME. And so here is an outline basically that describes that process. And so in this particular example, what's happening is that once you're able to establish a connection to the table, connection to the database, you're basically doing column filtering, row filtering to eliminate missing values, then calculating the group average by using the group by node, and adding that group average into the original table by using the joiner node. And at that point, you'll be able to write out the updated table into the original database, or you can just extract that information into KNIME table object. And so the difference between using DB database-based manipulation versus KNIME-based manipulation. So in order to answer that question, I'm going to show you another workflow. Okay. So let's see. Okay, I think there is a workflow right here. And so here's a workflow that is basically doing. So in this workflow, there are two different branches. The top branch is processing the data using database nodes, and the bottom branch is processing the data using KNIME nodes. And so these two branches are basically doing the same series of same processes to the same data set. So the data is read from the database. So a particular table has been fed into either of these branches. And as you can see, the sequence of data processes, what's happening is pretty much the same the top branch and the bottom branch. So we're doing group by to do some kind of group aggregation, and row filter to eliminate some of the categories based on the number of occurrence, joiner node to add aggregation information into the original data table, and finally sorting the data table based on some of the features. And at this point, what's happening here is that, so if you're doing all these processes using database nodes, and so what's happening during this process is that what you're generating is basically a series of SQL queries. And if you right-click on all these output ports, what you see are all these SQL queries as opposed to the data table. Of course, you'll be able to see the preview of the table that is going to be generated in this process. However, one thing I want to mention here is that so since this table has 11,000 observations, so in this case, it would make sense just to see the preview of the table. But so the point here is that all these DB-based and manipulation nodes only produce SQL-based SQL queries, and all these manipulation is conducted in a SQL database. And when you try to read this data into KNIME as a KNIME table object, that's when all the SQL queries are done and a data table is finally generated. If you try to do this process in KNIME, so the first thing you need to do is to read the data table using the KNIME reader node. In that case, what happens in the process is that, so at this point, you read the data table, which has 11,000 rows, and you do all these processes, and each of these steps, it produces a large table. It basically creates a copy of the original table, and if you keep doing this process over for a large amount of data, then it's going to take up quite a bit of resources on your computer. So so that the advantage of using all these data manipulation using the SQL database nodes is so that you'll be able to, you don't really have to waste your resources doing that kind of data manipulation on your computer. So now at this point, I'm gonna, let's see, I think we will switch over to, let's see, where's the slideshow? At this point, we're going to switch over to collaboration and knowledge sharing. And I'm gonna, let me start asking Anna the first question for this section. What is the meta node? What is a component that is different? What is a component and what is the difference between a meta node and a component? How can I reuse my colleague's component? And also, do I need a KNIME server to share components? Can I share my component also with the KNIME community outside of my company? So, so Anna is going to answer this question. So I'm going to stop sharing and so that Anna can share her computer now.
Okay, sounds good. So let me share my screen. Okay, you guys must be able to see my KNIME screen right now. And I have here prepared a small example to basically explain what is the difference between a component, a meta node, what can we use component for, and what is the big thing about them. So let's start with what is a meta node. So here in this first part, I read some data in. You see that the data doesn't look like a normal KNIME node. It looks like this gray node-like image with a correct sign. This is what we call a component. I can inspect the data from the component just like as I would in a KNIME node. And then you can see here, this is exactly the same data set as Satoru has talked about, with some customer information, with some information, for instance, about the gender, about the product they bought, about how long did they have a contract and how many contracts they had. Okay. So what is the thing about a meta node? If I double click on this meta node here, call data, you see this is gonna open, or maybe You're gonna see that this is gonna open another workflow. And you see that inside this workflow, there is much more complex than it would be. So you see that now we have all these table readers and there's some manipulation going on inside here until we end up with our data set. The thing is, the user who is seeing the first layer of the workflow doesn't need to see this. We can hide all of this complexity and make it neat and tight using a meta node. And that's what we do in this example. So meta nodes make your workflow nice and neat and hide complexity from other people. But let's see what is a component. So a component is slightly different. So let's see one use case for a component first. So first, a component can be used to share encapsulated knowledge. And what do I mean with that? Let's say here I do some pre-processing on my data that can include removing some missing values, removing some duplicated rows, or removing some outliers. Let's say I do this all the time, all my team colleagues do that, and I would like to be able to, instead of copying and pasting this everywhere, just encapsulate this nicely and share with them. I can do this using a component. I just want to also, before I make my first component, I want to call your attention for these green nodes here. We call them configuration. Those nodes are going to create a configuration window in my component. Let's have a look how does it looks like. So I'm going to now just select all my nodes here, right click and say create component. They're going to say that the nodes are going to be reset. That's fine with me. And I'm going to give my component a name like pre-processing. Oops, pre-processing. Okay, now you see I have a different node-like thing now, like in my component. It looks this light gray, but it can be changed the color as you wish. And if I double click on my component, I now see a configuration window. So for instance, if sometimes I don't want to remove my missing values, I can just uncheck this box. If sometimes I don't want to remove my duplicates, I can uncheck this box. This configuration window was created with the configuration nodes that I showed inside of this component before. So if I execute now, it's going to do all the pre-processing on the data without me having to do anything at all. But more than that, I can also share this component with other people, let's say with people on my company. If I have an access to a KNIME server, which I do have here, a KNIME server, I can, for instance, just right-click on my component, say component, share, and then I can just select where I want to share my component. Let's say I want to share my photo webinar. This is going to say, this is going to then create a new icon here on my KNIME Explorer saying pre-processing, and I can just drag and drop this into my workflow. I don't need to only share this using a KNIME server. I can also share this with the community, with other people in the community, the big open community KNIME, by just sharing to my KNIME Hub. So for instance, here I have my KNIME Hub, and I have a component already shared here, this component called post-processing. And if I right-click here, and I say open in KNIME Hub, it's going to open a new window with my component, and these other people in the large KNIME community can use this component. So you can share both in your team if you have a KNIME server, or you can share with the whole community. But the second important thing a component can do, and is really cool, is that it can create dashboards. So let's have a look here. Here I have a collection of JavaScript views, so they can be interactive. I have, for instance, a violin plot, some data explorer. I also have some text output widget. Those are all views. If I collect them together in a component, and I create a new component now, and say the component name is views, I can then execute this component, and then I can also go to this new option I have here called interactive views. If I open this, you're going to see it's going to open a new window here. Yeah. Somehow, I think took a bit of time. Okay, so now I'm going to open a new window with all those views I had before separately together in one page. That more than that can also be interactively. So for instance, here I have a slide filter that's gonna filter some of my values in my box plot, or my violin plot. So for instance, if I just do like this, you're gonna see that my violin plot is gonna automatically listen to the filter and change the values. This is one of the ways you can, for instance, create a dashboard with your data, and also then just deploy this as an application in the KNIME server, for instance. So those are the difference of about, let me go back to my slides and maybe I can go through this. Okay. Okay, good. So these are the difference between components and metanodes. So component metanode is basically just making your workflow nice, less confusing or more organized by putting everything inside of this metanode. But a component has more functionality than that. A component can be used to share some kind of process that you do all the time in your team, and to make this process flexible with the configuration nodes. Or it can also be used, for instance, to create dashboards and to make nice interactive views. And if you have a web portal, if you have a KNIME server, you can use this in the web portal to create an interactive dashboard. So these are the two big differences between metanodes and components. Okay, I saw that we did have a question before. Maybe we can talk about this question as well, if I can see the chat. Okay, Amir had asked, I want to connect KNIME to live data, and I want KNIME to read all the historical data once and only the new data next time it reads, rather than loading the whole data set from the database again. Is it possible? So what you can do if you don't want to read the whole data set all the time, if you have a database, for instance, you can say, you can parameterize your reading. So you can say, okay, now I don't want to read, if you have, for instance, a timestamp, let's say you get new data with a timely manner. Every day you get new data. And you want to read always the data from yesterday and not the whole data from before. What you can do is you can use those data manipulation nodes that Satoru has explained before to then parameterize your query. So you can say, okay, I just want to read everything that has this timestamp from yesterday, or the timestamp since 2 days ago. And then you're just going to read those rows that you're interested in. To connect KNIME to live data, what you can do is one of the things you can do, for instance, is not exactly live data, but almost live, is you could, if you have access to a KNIME server, you can schedule a job that is then gonna execute every, I don't know, 1 minute or 10 minutes. And this way you always, this workflow would always be executed with a certain period of time. So I think those would be my 2 suggestions for this question. And if it doesn't answer your question, just write again and let us know if you have more about it. Good. Cool, thank you for the question. Maybe the next then, what I'm going to be talking about is a topic that I really enjoy. That is, oops, deployment options. And this, we get lots of questions and they can be summarized into 2 things. For instance, how can I create an interactive dashboard for my results? The first question. And how can I export my application as a REST service? So let's say you have a workflow that you would like to communicate with another application. For instance, you would like to communicate with a website, and you would like this website to send some data, your workflow to compute something, and send this data back to the website, for instance. How can I then make a workflow available as a REST endpoint? So let's talk a little bit about that now, and then we're also going to talk how we can create dashboards. Good, let's go for it. Okay. So here we keep going on the same use case as before. Let's say I am reading here some trained machine learning model. So remember that with use case that Satoru has shown that he trained different models. Let's say we save this model somewhere, we selected the best one already, and we save it somewhere. And now what we want to do is to use this model to actually score new data. It can be from a database or from a website, be it. We want to reuse this model. So here what we do is we read this model and we use, for instance, in this case, a decision tree predictor to predict new data. What we have here that is the interesting part is that we do have 2 new nodes called container input and container output nodes. And these nodes are going to be what is going to create this REST interface in your workflow. So with the container input node, for instance, you're going to receive some input data that then is going to be used to be predicted and then post-process it. With the container output node, then you're going to get this data that was already processed in your workflow and make it available to your other application to communicate and use it. Here what I do, I have one initialization table. So one example here is the same data set as before, but only one row of it. And I want to know if this customer is going to churn or not, as an example. So I send this here, I predict, and once my prediction is done, I get this output here with a churn score. So we are 93% certain this customer is going to churn in this use case. If I have a KNIME server, then this workflow can communicate with other things inside of the KNIME server, so it can be called by other workflows, or it can be called by an external service. But let's say you want to know what is the API definition. You don't exactly know what your workflow expect and what your workflow gives back as a response. There is a nice way you can know this. So here is where my workflow is located. To know what the exactly API definitions are, I can just right click and say show API definition. This is gonna open the Swagger. And Swagger is basically a open source framework that is integrated in the KNIME server and also allows you to then inspect your API definitions. So let's say this is my API definitions for this workflow. Let's have a look at the execution options. So you're gonna see here, for instance, a execution URL. You're gonna have some information about parameters you can set, and you're also can see your request body. And then you can see an example value of what your request body should look like. And you can also inspect the schema, how this request body should be organized. And then you can also see, for instance, what kind of response you should expect. If I execute this workflow, if my application that connects to this workflow then calls it in, Then this is going to generate a new job in my KNIME server, and this is going to then read the data in and output the data to be used as a JSON format to other applications. Okay, so let's have a look how this actually works inside of the KNIME server. And here now we're going to make use of a dashboard. So the use case here is the following. Let's say you have this nice model that already knows how to predict when a customer is going to churn. And now you want to be able to allow other people in your team to interact with this workflow without actually having to know what is going on behind it. So let's say I want to select the customers that have a high probability of churning, so leaving the contract, and try to contact them before they do churn. So try to do some to save the contract, for instance. So what we do here is we have a component that's going to create one page in our portal where the user is going to log into a database. And then what we do is we connect to our KNIME server and we call that scoring workflow that we had before. Then this scoring workflow is going to score the new data from the database. And with these two other components, we're going to let the user to select customers to contact and also to then browse and download this customer list. So how does this look like? How can I actually execute this? I can just right click on my workflow, say open and web portal. This is going to open a web portal page. So this is my web portal. If you have a KNIME server, that's how it looks like. I can just start the execution of my example. Behind it, I have a workflow running that then is going to show only this page for the user. The user only sees the database login page. Doesn't need to know all the complexity behind it. If I press next, then this is going to now score. My user has already logged in the database. This is going to score the new data. And then I can allow my user then to select, okay, I just want to get the customers that really are going to really churn, like for sure, let's say, very trustful that it's going to churn from this product in specific. Then I can press next. And then the workflow is going to execute. And I then get a list of these customers that I should contact because they have 93% chance of churning in this use case. The cool thing is that the user only sees this, but behind it, we have components that creates those web pages. So I don't have to code anything. This is made by components. And those are all done underneath the hood by this workflow. So those are two examples in deployment in which you can then use to create an interactive dashboard for your results. So we talked a little bit about, let me make this larger now. We talked a little bit about how to use two-user workflows as a REST resource with the KNIME server. We also talked about how to look at the API definition with Swagger, and also a little bit about our web portal to then deploy and create nice dashboards. Okay, so let me check if we have open questions. Okay. I think, do you have any questions regarding anything of what we talked, or any open questions in on the breakout rooms? Okay, if not, then I think this is what Satoru and I had to talk today. We are happy to answer any more questions if you have any. Okay. Okay. Maybe I'll give one more minute to see if you guys have any questions or any open things to discuss. There is one question by Dulce Lopez. Sorry if I didn't say your name correctly. Is it possible to have a general overview or training of KNIME for the people in the company I work? Yes, it is. You can get in contact with us. I can also, maybe we can follow up. I can also give you I can follow up with your email. We have it there when you registered. Maybe we can send you an email to follow up about that. Or you can also send an email to contact@knime.com. Yeah. And then we can talk about it. It is possible. You're welcome. Yeah. Okay. So let me see. Satoru, do you have any other questions you would like to discuss or anything?
Yeah, sure. So there is one question about deployment. So I don't, you might be able to shed a light on this. So I'm very interested in being able to reuse my model. Can I save my model to reuse it later or a new data set? Can I share my model with my colleagues? Can I create a dashboard for seeing my prediction? So being able to share your workflow with your colleagues. So
yes, definitely. So I can just go back to KNIME maybe. Oops. Okay, so this is one of the things you can definitely do. For instance, all models in KNIME can be saved to your disk, for instance, and then can be reused. So for instance, here I have my model. So this is my KNIME server, and I have my model here called my churn model. I can have people have access to this model because I can give permissions for people in my team to have access to this model. And all they have to do is to then read this model into the workflow, and it's gonna then be used. So that's what we do here. We read this model in. So for instance, I'm reading my model, and we use this model then to predict the new data. This can be easily reused by other people in the company or other people in your team. They can just have access to your workflow if you want them. You can set permissions to specific users, and then they can just or reuse your workflow or reuse your model and so on and so forth. So you can, once you have a nice model that you think it's ready to be put in production, you can then just save it and reuse it as you want.
Okay, thank you very much. Okay, so related to that question is that so is it possible to use a component created by other people that are available in KNIME Hub, and how can we do it?
That's a very nice question. So let's go to hub.knime.com. Okay. So here you see in hub.knime.com that we have a certain number of nodes that you can look like. So here is our search engine. And then you can find workflows that the community shared with you, nodes or components or extensions that we have. So you see that here I can look for nodes, workflows, or components. And then we can look how many components we have. So these are all the components that, for instance, we and KNIME have provided. So we do our components, we test them, and we put them available for other people to use in the community or from people from our community. So not KNIMers, not people who work in KNIME, but people who use KNIME and wants to share the processes. So let's have a look at this component, remove seasonality. This is one of the components that we created at KNIME. You see that is slightly stylized. I don't know how to say it. It has some style, so it has a color, it has an icon, similar to how a KNIME node would feel like. And if I want to reuse this node, what I can actually do, which is very neat, I can just drag and drop this into KNIME. And this is then going to create a component for me to use. So once I found a component, and this also works with normal KNIME nodes, I can just drag and drop this into my KNIME workflow, and then I can use it as normal. What I can also do is I can also look at my component description. So similar to nodes, components have descriptions. So if you don't know how it works or what the data expects or what kind of output it has, you can have a look at the component description, and it's gonna guide you through how to use the component. So this is a good question. Awesome. Awesome. So I think we are good. Let me then go back to my, make this slightly bigger. I think we are good. I would like to thank everyone. Satoru, do you want to say something?
No, I'm good. Yeah, thank you very much. So yeah, that was really nice. Nice answer. Yeah, thank you very much for that question. Yeah. Answering that question.
Yeah, awesome. Thank you everyone for participating. Feel free to ask more questions in the forum if you want. We're going to be we always look at the forum and answer the questions. And yeah, thank you so much.
Thank you very much.
Bye.